All right, so before we did questions 1 through 6, so now here we're going to do questions from 7 through the end, okay? All right, so here this asks me to factor the polynomial completely. So I see 9x squared plus 100, okay? Well, first I'm going to look for writing in standard form. Well, it already is. It has the x squared first and then the term with no variable second. So second, I look for a GCF. Well, the only thing that divides into 9 other than 1 is 3 and 9. Well, neither of those divide into 100, so there's no GCF. So next, I'm going to look for what do I got. So I see a binomial. When I see a binomial, my first thought is, do I have perfect squares or perfect cubes? So 9's a perfect square, x squared's a perfect square, 100's a perfect square, but it's a plus. So remember, like, we cannot factor a sum of squares. So there's no GCF, we can't factor sum of squares, so the polynomial cannot be factored. So we should just have a polynomial cannot be factored here. All right, let's move to number 8. All right, so in this case here, I'm asked to factor this completely. So again, it's in standard form, cool. Next thing I'm looking for is a GCF. So I see a 3 here. I could divide a 3 out. So I write a 3, and then that leaves me with x squared minus 16, okay? Well, now that's a difference of squares, right? So going back to my perfect squares pattern, x squared minus 16 would factor into x minus 4 and x plus 4. I bring down my 3. Now I need to select, notice there's 1, 2, 3 parts to this answer. So I select all 3. 3, x minus 4, and x plus 4. All right, number 9. Okay, so here I'm asked to factor this trinomial. Now notice it doesn't give me a b value, so we got to think a little bit more here, okay? So here it reads x squared plus b plus 18. Well, if I was going to set up my factoring, I would do, this is like an implied 1, right? So 1 times 18, but I don't know what b is, right? It's a question mark. So it could be anything as long as the numbers multiply to 18, right? Okay, so what could I do here? The first thing that comes to my head when if I'm asked for two numbers to multiply to 18, okay, is 9 and 2. Well, if I write 9 and 2, then what would they need to add to? They need to add to 11. So then in the blank, I would type in an 11. Now, did I have to do these? No, I could have done what? 1 and 18, and it could have added to 19. I could have done 3 and 6, and it could have added to 9, right? Heck, I could have done negative 3 and negative 6, and it could have added to negative 9, right? So as long as it would then make it to where you could have those numbers, you would put the b value that works for that scenario. Okay, so that's number 9. All right, let's look here at number 10. Okay, so number 10 here, we've got 27x cubed plus 1. So again, you always look to write it in standard form. It is. Then you look for a GCF. We don't have one. So now you look for, well, what do we have here? I have a cubic. Okay, so I have a sum of cubes. So I'm looking to take the cube root of everything. So the cube root of 27 is 3. Cube root of x cubed is x. I copy the same sign. I cube root the 1, it's 1. Now I do the first term times itself. So 3x times 3x is 9x squared. I multiply the terms together. So 3x times negative 1 is positive 3x. I need to negate the plus 3x, so I'm going to write negative 3x. Then 1 times 1 is 1, so I'm going to finish with that plus 1. So I would write 3x plus 1 for my binomial, 9x squared minus 3x plus 1 for my trinomial. All right, let's look at question number 11 now. Okay, so here we're asked to type the answer of the factors below and then explain in words the process you use to get the factor. Okay, so here really the words that I say out loud is what you should be typing for part B. Okay? Okay, first I look to see if it's in standard form, and it is. Next I look for a GCF. There is not one. So then I see I have a trinomial, so I'm going to set up my factoring. I'm going to do the a value of 3 times the c value of 4 and get 12. Then I'm going to look for my b value of negative 8. Next, I need to think of numbers that make this scenario true, where they multiply to 12 and add to negative 8. So those numbers would be negative 2 and negative 6. Okay, next I'm going to set up where I bring down my first term to get 3. Sorry, my pen is not cooperating very well here. 3n squared. And then I'm going to bring down my last term for the plus 4. I'm going to split the middle. So I'm going to get my numbers that I just got here. So I'm going to put negative 6n, and then I'm going to put negative 2n. I take a GCF out of 3n. I divide, and I get n minus 2. I take a GCF out of negative 2. I divide, and I get n minus 2. I know I'm correct because the interior terms match. So I write n minus 2. Then my two GCFs form my other factor, which is 3n minus 2. That would be my answer there for number 11. All right, let's look at number 12. So for number 12, I would need to try to factor here. So here this problem reads x squared minus 4x minus 12. And this is what this student got, x minus 2 and x plus 6. And so then it says, is the student's response correct? How can you tell? So there's really two ways to do this. One is I could just ignore what they did, do the problem myself, and see if I get the same answer. Or I could multiply this all together and see if I get back to what they started with. Either way would be fine. I'll show both. So if I multiply through, x times x is x squared, x times 6 is 6x, negative 2 times x is negative 2x, negative 2 times 6 is negative 12. From there, I'm going to combine the like terms of 6x and negative 2x. So I get x squared plus 4x minus 12. So now, did I get the same thing? No. The problem was negative 4x. They got positive 4x. So is the student's response correct? No. How can you tell? Well, I multiplied it through, and my middle term is not the same. That would be a totally fine way to do that problem. A totally different way, but yet also okay, would be ignore all this and just factor it. So I would set it up, multiply to negative 12, and add to negative 4, which should be negative 6 and positive 2. And then I'm just going to factor. So x squared plus 2x, and then minus 6x minus 12. I take a GCF out of x, I'm left with x plus 2. I take a GCF of negative 6 out, I'm left with x plus 2. I know I'm right because they match, so I write the x plus 2 one time, and then I write the x minus 6 another time. So what did I get? I got the same thing as them numbers-wise, but the signs are opposite. So then that's what I would say here. Is it right? No. How can you tell? Well, I factored it, and I got different signs. Either way I just showed would be a fine way to answer this problem. All right, number 13. Okay, so here it gives us this problem, which is x cubed plus 12x squared plus 9x, okay? And then it said the student gave the following answer and explanation. So the factored form is 3x, and then they have x squared plus 4x plus 3 on the inside. And they put for their reasoning, I know I'm right because if I multiply my answer out, I get the original problem. Okay? It says the student's answer is not correct. So in A, I'm supposed to explain with words the error, and B, give the correct solution. Okay, again, what I'm saying are the words you should be writing. Okay, so they were right to say I need to take out a GCF of 3x, and that actually is the GCF. So I eventually take out a GCF of 3x, I get x squared plus 4x plus 3. But here's where they had an error. They just stop here. The reality is we can still factor what's in here. So we're going to do 1 times 3 is 3, and it needs to add to 4. Well, what multiplies the 3 and adds to 4? 3 and 1. So now I'm going to bring down my x squared. I'll put my 1x with it. I'm going to put my 3x and bring down my 3. I'll take a GCF out of x. I'm left with x plus 1. I take a GCF out of 3. I'm left with x plus 1. I know I'm right because they match. So I'm going to write that one time, x plus 1. The two GCFs, x plus 3. And then the original GCF of 3x. There we go. So what was their error? They could have kept factoring, and they didn't. So that should be the solution. Okay? All right, number 14. Okay, so here we go. We have a review question here for number 14. So it asks us to simplify this expression, and it gives us 3x plus 4 squared. So let's remember what squared means. So 3 squared, for instance, means 3 times 3, which is 9. So it means multiply times itself. So when I see 3x plus 4 squared, I'm going to do 3x plus 4 times 3x plus 4. And now I'm going to multiply through. So 3x times 3x gives me 9x squared. 3x times 4 gives me 12x. 4 times 3x gives me 12x. 4 times 4 gives me 16. Now I need to combine like terms. 12x plus 12x is 24. 4x, I bring down the 16, I bring down the 9x squared, there we go. Okay? Alright, let's go to the penultimate question. Alright, so number 15 here, it asks me to actually take all this and then I need to rearrange these in the order that works. So, it's asking me to position this. So I see that I need to reorder ax squared plus bx plus c. Okay, so first thing I'm always looking for is to write it in standard form. So if I don't have it like that, I need to write it in standard form. So I see that right here. I'm going to move that to the top. Then we always look for a GCF, so factor out the GCF. Again, remember, plenty of times there isn't a GCF, so that's why it says if there is one, you know. All right, so then from there, what do I do? So I need to figure out those numbers when I create the x. So I split the middle term by finding the two numbers that multiply to give me a times c and add to give me b. So that needs to come next. Once I get those numbers, what do? Well, I group together the first two terms and the last two terms where I create the two sets of parentheses. Then I factor out the GCF from the first group and from the second group. And the last one I do is I factor out the common binomial. So when I have those two in common, I put that one, then the two GCFs form my other factor. So there are my steps. Now again, let's say you're doing this and it's just too abstract because there's no numbers. Couldn't I go back and forth and go, wait, let me go back to a question. Let me see what I did here. Let me see what I did here. Oh, okay, that's what I did. And then jump back and forth. I mean, I think that's a good idea. All right, last but not least, number 16, the review question from Unit 1. We're asked to solve this absolute value equation. So remember, when we solve an absolute value equation, the first thing is we want to get the absolute value alone first. So to do that here, we would add 1 to both sides. So that leaves me with x plus 6 equals 4. Now I see the absolute value is equal to a positive, so that's good. If it was equal to a negative, we'd just say no solution. So now I split into two equations. What was on the inside, I copy, it does not change. Notice how those are exactly the same. I switch the sign. So the first one is just 4, the other one is negative 4. And now I solve. So I go minus 6 to both sides, x equals negative 2, minus 6 to both sides, x equals negative 10. So these would be my two answers. So I go into these boxes and type those two answers in. Hope this two-part review helped. Send me a message, Canvas inbox, if you have any questions.